really what we're trying to do is build smarter exports to turn these behaviors into more structured insights that can be ready for modeling, strategy, action.
Welcome to the Innovation Forge.
Today we explore feature engineering as presented in my Slate 2025 conference presentation. Let's see how innovation meets artistry as we forge something extraordinary together.
You are listening to the Innovation Forge, the #1 podcast on adaptive enrollment management, exploring the data, marketing, and strategy that fuels higher education. Here's your host, David Dysart.
Hello, Guilders, and welcome to the Innovation Forge. I am your host, David Dysart, and I'm thrilled that you are joining me on this journey into the innovative world of higher education and adaptive enrollment management. Hello, Guilders, and welcome to a slightly different version of the Visiting Artisan episodes. I had the chance to present at Slate Summit 2025, and for that session, I did what was basically a brief intro or overview of some feature engineering that is possible in Slate. And I wanted to take some time in video format to actually build those exports and joins and filters, and that just was not going to happen in a 20-30 minute time slot at Summit. So I wanted to record these videos to give folks an opportunity to have that hands-on experience, see how these things are being built. I'm also including like the suitcase to also help with those finished pieces, but I definitely feel like giving people the opportunity to learn hands-on as they watch someone doing it is definitely going to help some folks. So in the first episode, we are building flags and counting behaviors. These could be attending events, or logging in, or sending emails, opening emails. And we're actually going to do two different versions of flags. So we'll use filters, and the other way we'll use counts, and we're just seeing if there are any counts, then we'll just say, yes, they did attend these events. Next, I cover score bands, and we use the particular use case of email click rates and being able to bucket those click rates into bands that have similar behaviors, similar group sizes, and those kind of relevant pieces. And the last piece that we cover in the first video is distance. How far the student's school or permanent address is from your institution. In the second video, we cover time-anchored behaviors. And this could be counting behaviors that happen in the last half of April, or if the student registers for an event within 7 days of them getting their admission decision. And then lastly, in the feature engineering piece of just more miscellaneous engineering, we look at building an entity that allows you to track historical engagement scores and predictive modeling scores, so you can understand year-over-year comparisons, how the population as a whole is changing engagement throughout the timeline, and how individuals are either heating up or cooling off in their engagement. Summit presentation, I also group in this miscellaneous feature section coalescing decisions. So when the student applied or was admitted or deposited, with some kind of backfill time stop or a deadline. So we are only counting behaviors until the student deposits, or if they haven't deposited, then maybe the May 1 deadline. And we're using some additional formulas to make that a little bit more evergreen year over year by pulling in like their round year or application term or entry term, whatever the particular Slate field is for you. So I definitely want to take a chance to get a little bit more hands-on with these, a little reminiscent to the workshops I used to run for Beyond Academics, but this is just very targeted feature engineering. I think this is going to be really helpful for the very technical folks who want to learn configurable joins more and do some fancier things, but also just a good example for maybe your senior leadership or your Slate captains who might not be as hands-on on the data or technical pieces, for them to understand what is actually possible with Slate. And this just gives them a good primer as to what can be done. I'll also link to the PowerPoint session that I put together for a conference, and that might also be good for senior leadership to kind of flip through, just again to get an idea of what's possible with configurable joins. Attendees at this session also got a 50-page abridged version of my book, The Innovation Forge, that covers feature engineering and Slate configurable joins. But I think we'll just leave that for those particular attendees. You can, of course, buy the ebook, audiobook, not the audiobook yet, still working on that, but the ebook and the print book. The original conference presentation, I had actually planned on also adding in some exports on how to aggregate scores and models, building like the logit and the probabilities 0 to 100% and ensemble modeling. Very quickly realized that what was more interesting was this feature engineering piece, especially with the time allotted. So I think I will probably record a third video at some point that does go through those pieces and also allows you to do this prescriptive nudging with the model. And actually, that's probably going to be 2 videos as well. Maybe next calendar year, we'll do a couple more of these sessions. But I hope you have a good time watching the video and can definitely get some good use out of it. If you have any ideas to make this process better or new use cases, especially with the sequential value groups, I'd love to hear it. Drop in the comments, send me an email, message me on LinkedIn. I would love to get better at these kinds of pieces. And maybe we can also feature you on a future interview on the Innovation Forge podcast. With all that talky talk up front, let's get into it and see how feature engineering takes shape today. Hello, everyone, and welcome to this Workbench walkthrough. I wanted to take the opportunity to cover the topics from my Slate Summit 2025 conference session and actually work through building these feature engineering exports with you as we go. And we'll be covering things like counting and flagging behavior. We'll create score bands for things like click rates and scoring rubrics. And we'll do distance from the institution, looking at both the student's permanent or school address and coalescing those. Time-anchored behaviors such as maybe you want to count events that are happening on specific months or days of the month, or even counting behaviors that are happening right after those moments that matter, like when the decision is received from the student. And login streaks, so how many times consecutively, either daily, weekly, whatever it is, their student is logging into their portal. Or we're also going to cover that historical tracking score entity that I built. So let's get into this and start our query. I'm just going to build a new query here, call it feature engineering, and maybe we'll call it feature engineering. And you can see here I'm just in a clean slate test environment, clean slate environment, and maybe just toss that in a folder. Doesn't really matter at this point. We want records because we're going to be doing application base. That just means for every application in your instance of Slate, it's going to return one row. And luckily the clean slate has some applications for us to work with here. And we're going to want to do some joins. So specifically, we're going to do a lot of work around those decisions, whether that's being admitted or deposited. So we're going to add a subquery filter. Actually, let's just do some joins first. So we're going to do a subquery join. And we're going to join to decision. And we'll do the decision one to many, because we're going to add some filters to it. And we're just going to name this maybe decision accept. And we'll create the base for decision. And we're going to add a filter of code, because that gives us the option to choose which decisions we want. And let's do admit. And we can sort this by decision date. And maybe we want confirm date. And this would give you that first admit, but let's go ahead and do a descending sort, so we get the most recent admit decision. And we're just going to copy that for deposit. And maybe your institution calls it enroll. I think, yeah, the clean slate instance calls it enroll. So we can just save that copy. And we're going to join to the person, because that's going to make our life easier, probably. And first I wanted us to cover a topic. This is going to be one of the more complicated topics probably, just because it's a lot of exports and filters. But just since we are talking about decisions, let's go ahead and build maybe a starter export. Behaviors with decision date. And we're probably going to do some formulas. And we're going to add an export. So let's do a subquery export. This gives us a little bit more flexibility of how we're going to pull this data. And maybe we want to join to form responses. And let's do form responses that are coming from that person data table. I typically like doing these all forms and events because we can continue to add filters to the specific types of events or specific folders that you're interested in. It also allows you to copy and repurpose that export or filter for different, maybe on campus versus virtual versus off-campus events. So I typically just do all form and events. And let's go, we're just going to name this specifically person form responses. And this is the actual join that we're renaming, just to make it a little bit clearer when you are adding filters and exports, what kind of data table path you're using here. And we're going to join from form responses to the form, because there's going to be a lot of information that lives on the form itself and not the form response. Then there's going to be things like templates, folders, event dates, things like that. So let's add a comparison filter here. And we're going to compare, let's see, form start date. So this is the date of the event and the time, but we're going to be more concerned about the day, really. And we're going to make sure that we want to count any events that were happening before the student deposited. But there are going to be a group of students who you're probably analyzing who didn't deposit. So we're going to use a separate deadline for them. So maybe it's the May 1st deadline to commit or enroll or deposit, whatever your institution calls it, for that population. Because as a student matriculates or deposits, they're probably getting new emails. There's probably new events that are happening for them. So we only want to count these kind of post-admission, pre-deposit window of events, engagements, behaviors. So we want to count form start dates that happen. Let's just do less than or equals to. And this is going to be one of the trickier exports that we build here, because we're going to nest inside of this the decision date, but also that deadline date. So we're just going to do deposit created, and then we're going to coalesce that with maybe like a 5, 1, and then around. So we're going to use this coalesce, which just means we're going to stagger exports. And if the first export does not exist, it'll go to the second export. If the second export does not exist, it'll go to the third export. We're just going to do 2. So let's do decision, deposit. We're just going to do created date. And then we're going to build that really evergreen deadline, because you might be pulling multiple years of data, or you might not want to update this every year, especially if you have a lot of exports that you're probably building, maybe tens, hundreds of exports if you're doing like an engagement score or an enrollment model. So it's definitely easy to just let Slate do kind of that heavy lifting. So we're going to do another formula here. And we're going to concatenate, and this just means we're going to splice together several either data pieces or strings of text. We put that in a parentheses. And we're going to leave a little bit of space for our year. And we're just going to say, maybe we're going to use, let's say, 0501. 05 being May, 01 being the first day of May. And we're going to add another nested export. Sorry, y'all. We're going a little deep on this one, but the automation here really does help if you are building a score or a model. And we just want the left 4 of the round. And this is also just going to assume whatever your naming convention is for your rounds. If it's 2024 regular decision, or if it's regular decision 2024, then you'd want to do the right 4. So we're going to do another formula here. And we're just going to do left. We're going to leave space for our data. And we're just going to say we want the 4 leftmost characters. So we can just do round name. I'm going to join from our application to our round data table. And then if we do the @ symbol, we get our drop downs of our exports here. So I want the left 4 characters of our round name, which is going to be the year that the student is applying for. And we can save that. And again, if your naming convention doesn't work with rounds, maybe you have a prospect term or an application term that you can use. And we'll just do that @ symbol. So if this is 2025-0501, we're going to compare our form start date essentially to this. And we can just give this a date value. So we have this. So if the decision created date exists, give us the date, and if not, give us that adaptive enrollment deadline. So we're going to say if the event start date is less than or equal to that deposited /deadline, and we're just going to maybe call this event before deposit or deadline. So when we're doing an aggregate where we're counting the number of events that the student could be attended or registered, that's going to happen before the deadline or the deposit. So we're just going to go count events. And we'll do some additional filters here in a little bit. I just wanted to show, this is just going to show the number of events, how we're going to build this coalescing date throughout these videos. So we can just save that as an export. Next up, we're actually going to start counting behaviors. So we're going to go ahead and make a copy of this behavior with decision date. So let's see, we're going to count events. Yeah, we can just do counts events. So let's be a little bit more specific with how we are filtering our events to do our counts. And so we are joining to the person data table, person to form responses, and form responses to form. So we do have a lot of information both at the form response level and at the form level. So let's add a few more filters. And we'll just do registration status. And this is that form response registration status. So this could be things like attended, no-showed, things along those lines. So if you could be granting points for attending events or subtracting points for no-showing events, this is going to give you the option to specifically count those event engagements. So we're only counting the events the student attended. So if a student has an upcoming event they're registered for, this won't count them. You could still filter that. Maybe you want to do half points for registered events. You can do that here in this registration status. So we have the event before the either deposit or the deadline. And we can do things like filter on that form template. Let's see if Clean Slate has anything. So these are all just Clean Slate delivered templates. Maybe we want to count admit student days. And you could, maybe if you wanted to do a combination of templates and forms that are actually living in folders. So we can just do form folders. And maybe you have some non-admitted student day templates that live in the admitted student day folder. You can add those there. And maybe you want to only count the type of form, because this is the form data table. So this is actual like forms like RFIs, it's events, and it's the interview scheduler. So if we also filter for the form type, we can count, maybe I only want the actual events for admitted student day, and I want to exclude the interviews that are happening there. So this gives us a broad selection of filters that allows us to count specifically what we want. And we're just going to get a generic count. So if they went to 5 events or 4 events, 3 events, whatever it might be at the application level. And maybe you also want to add interactions. Maybe you have a spreadsheet that you just upload the interactions to. And you're not able to tie those to a specific event because you're just not creating events for those. But the interaction's a strong enough tool for your use case. You could build those out. Again, I would definitely utilize that date comparison feature. And if you are uploading or creating those interactions, have the interaction date be the event date, not just when you uploaded it. That would be really important for doing these kinds of comparisons. And if we do have multiple types of events, and this could even be, maybe you want to count guided campus tours and another export for self-guided campus tours and another export for academic campus tours. Adding these additional exports becomes easy to count at a broader level with a formula. So maybe we do this instead of events, we do scheduler, and we do interviews. So I want to count, so I'm going to slice this data up in several different exports, but for this one, I want to count events and interviews. So I can actually count the actual events and the interviews. I can also weight these in a scoring rubric. So maybe I want to count events, or I can weight it or apply a specific scoring rubric. So I want to apply 5 points for every event, and I only want to apply 3 points for an interview, or whatever your scoring rubric might be. And because these are counts, you should be good on this being the correct data type. If this is, say, for some reason, your data here is like a formula, and you're getting into some errors, you can format type maybe a integer or a real if you need decimal points. But this does give you a lot of flexibility on how you're counting behaviors, what kind of behaviors you're counting, and even applying the scoring rubric directly in your export. And in a future video series, I'll walk through my process of creating scores and predictive models that run and automate directly in Slate. That's not necessarily feature engineering, so that's definitely going to be a later element of this. So maybe just save a copy here. And we're also going to flag events. And we're going to do this in 2 different ways. The first version really piggybacks on these counts. So we're going to say case when. So this is if you're like an Excel person, this is just like an if statement. So if whatever your formula is, so events plus interviews is, let's say, greater than 0, then apply a 1 or apply a yes. Else 0. And we're just going to do ones and zeros. It's a little bit, at least for my use case, best practices is just 1 and 0. It's binary. It's a lot of data that are actually coded in Slate as binary, and then just displays a yes no on the front end for the better user experience. So, and then we're just going to end our little formula here. And this is actually just going to give us a flag of, did the student attend any events or interviews? And we can just remove these scoring rubrics here. So this is probably a little bit more computationally intensive than using filters, but again, we do get a lot of flexibility with how we're flagging events, what events we're flagging, being able to copy and paste these exports from counts to flags and flags to counts. And you could also, again, applying that scoring rubric. So maybe you want to say, if someone attended any event or interview, I just want to give them 15 points, else give them 0. And we can do that in the second version of flagging we're going to do here in a minute. But this does give you that chance to build a yes-no flag or a scored rubric of types. And we're just going to go ahead and save a copy of that. The next piece we're going to cover is a different type of way to flag events. So we can just grab a subquery export here, and instead of doing a formula that handles the counts and does that kind of case when comparison, we're just going to build it in the filters here. So it's probably a little bit computationally more efficient. And maybe you use these kinds of flags over here with the comparisons to identify what types of behaviors you want to count versus what kind of behaviors you just want to flag. And then maybe you follow up for your automated run with this kind of way to flag these events. So we're just going to do flag event. Let's just call this a v2 type of flag. So we're going to change this to existence. And again, we're just going to give this a 1 and a 0. Just like we did in the former one, we could just say, like, we could also add our scoring rubric directly here. So if the student attended any events, give them 15 points. And this also works really well as a way to add bonuses. So maybe there's diminishing returns. So a student who attends any event at all is highly correlated with someone who's going to apply or enroll. So you can add this bonus of, okay, we're going to give the first event someone goes to 15 points. And then, but we're also going to count the number of events the student attends. Maybe they get 5 points per event. So you're able to get 20 points for that first event, 15 here, 5 for your count. And every event after that is just an additional 5 points. And then helps balance those kind of not linear behaviors that you might be dealing with. You can also just create a more intricate scoring rubric inside your formula, which we'll cover when we do click rates. But this is just a nice 1-2 comparison that's really simple at a glance to look at rather than a really complicated scoring rubric that's built into your formula. So we're just going to do a couple joins again. So form, response. Maybe we're just going to join to application this time. We're going to do all forms and events. And we're going to join to form from that form response, so we can get things like template and type. And we can just do type. Maybe I just care about any scheduler. We don't care about if it was on campus, off campus, templates, folders. We just want to know if the student attended any scheduler events that were application scoped. So we give that. And there's just 2 different ways to flag events. Next up, I want to look at scoring bands. And we're going to use a more intricate behavior here. So we're going to actually, we can make a copy of our behavior with decision date, just because that already has that coalescing deposit deadline. So we're just going to make a copy of this, and we're going to do click rate pre-deposit. Maybe pre-deposit, students have a very specific click rate that you're looking at, or maybe if you want to look at this post-deposit, it's still going to be the same. You can still use the same approach to comparing against decision dates. So instead of joining, though, to our form responses and then form, we're actually going to be looking at emails that the student is receiving and then how they're engaging with those, whether that's opening them, clicking them. And this comes, of course, with the big asterisk of there are services like Apple Mail that is opening and clicking things, the emails that are coming to the student. But that's also why we're using this as an example for score bands, because we can look at those students with 100% click rate, and maybe they behave very similar to the students who don't open anything because it's just the system opening and clicking emails. So we can actually apply our scoring rubric and treat them as if they opened 0 emails. And of course, there's noise in that. There are going to be some students that did open and click every single email you sent, but probably not a lot, if at all. So we're going to use this pre-existing export that we have, but we're going to change things up a bit. Maybe this is emails sent. And we're going to, just as a placeholder, so we can delete this form start date. And delete this join, delete this join. And we're just going to join from the person table to messages. And of course, messages has 3 S's. It's very common English confusion that's only 2 S's. So we're joining from person to messages. And we'll update this in a second. But let's look at some of the filters you might want to be using when you are going to be counting emails being sent to the student. So maybe we just do messages method. So we only care about emails versus like SMS text messages. And maybe we want to look at the type. Well, we are most certainly going to want to look at the type because that distinguishes if a student is sending the message So like an external message is an email that's moving into the Slate instance from, this could be the student emailing you, it could be the counselor, it could be a parent. It's those emails on the student timeline that are coming into Slate. And you might have to assign that email to the student record, especially if the student has multiple records or there's multiple email addresses, or like I said, it's a counselor or a parent that's just not going to catch on the student's record automatically. But we're just caring about the students receiving emails. So this is deliver mailing is the emails that come through deliver. Form communication, maybe they signed up for a form and they got an automatic confirmation email or a reminder email. And then ad hoc messages, if you're on the student's profile and you click on their hyperlinked email address there on the dashboard, and that opens up that pop-up that gives you the opportunity to email them. That's ad hoc messages. So we're just caring about all of those types. And again, there's probably some nuance between those types of 3 emails, how important they are, what kind of information is being delivered, but we're just looking more broadly at all emails being sent to the student. And if you want to look more specifically at status, these are all mutually exclusive. So a student whose status is in click, we want to count that, as well as maybe like send and open. There's a lot of pieces here, as well as like if they were skipped because it was a duplicate email, or if they were opted out. There's lots of options here. We're not going to go through all these details, but let's just click on clicked, delivered, open, sent for this use case. Because these are basically emails that the student has a chance to click or open. We're not looking at like, oh yeah, this student's email is bouncing 5 out of the 10 times we emailed them, so they at most have a 50% click rate or open rate possibility. Just not looking to get into that kind of nuance with this specific export. So we also want to look at these email behaviors that are happening maybe before deposit and after accept. So that window, maybe March, April, that you're working with, and being able to more strategically do your outreach to them. So let's just do the message delivered date being before that deposit. And we can just make a copy of that. Maybe we want after admit. And we want specifically emails that are happening after the admit decision was actually opened or received. So we're just going to inactivate that so it doesn't have to calculate it. So we're going to do decision. Let's just see that received open dates, because we're really caring about how the student is reacting to the institution's decision to admit them in that window before deposit. So maybe you confirm it a few days before the decision is released, and maybe the student didn't get it until a week later. We really want to know about that nuance of the student knows they're admitted, and before they're actually depositing, what these kinds of behaviors are. So we're just going to look at message delivered date, and we're going to say this is after. Oh, I did decision. Sorry about that all. I want the accept date, not the deposit date. And I'm going to leave this in because editing. And I'm human. So we're going to look at messages being delivered after the decision was received or opened. So we're going to save a copy there. And then I didn't actually messages delivered date. There we go. Very human, guys. Okay, so we're going to count all of these emails. So we're going to save that. And maybe we also want to look at emails opened. So we're going to change the status and remove sent and delivered. So these are students who opened and clicked emails. So because these are mutually exclusive, we do need both of those, unless you want to count just people in that limbo of opened but did not click. So we're going to leave that. And we're going to do clicked. And maybe you just want to have these data points of how many emails did we send to the student, or how many emails did they open. We can just save this. And I think this is a good point to now transition into that click rate and applying score bands. So maybe we want to make a copy of this. So we just built how many emails were sent to the student, how many they opened, how many they clicked. And these are all specifically counting after the student had received their admission decision and before they deposited. And if they didn't deposit, that application or commitment deadline. So what we're going to now do is actually just calculate the click rate. And there's the simple way to do this that's probably going to break, and then there's the more complicated way that will kind of help error-proof what's happening. So we're going to do, let's see, email click rate, so email clicked divided by email sent. And you can even do subsets of the emails they opened, what was their click rate of opened emails. The problem with this is if for some reason, I mean, like I said earlier, since these are counts, you should be getting a properly formatted integer to do these kind of mathematical formulations on. But maybe they didn't click on any emails at all, or weren't sent any emails. So you're dealing with these divided by like 0 situations, and that's probably going to cause an error as well in your query. So maybe we want to cast both of these as, let's just say, real numbers, could be integers, and we also need to do a null if statement. So cast is basically just telling Slate, hey, make sure that this variable, this data, this formula, export, however you want to call it, as a real. Or we could do integer, but let's do real in case we need decimal points for your example and you come back to this video needing to do something. And then we can just close the parentheses, and let's cast this as well. And just make sure whether you're using integers or reals, you're using the same data type here. So this does solve errors of data types, but it doesn't solve the issue of if we're going to get other types of errors here. So let's just do a null if statement. Just do a 0 here. So this will help, like if they just didn't get any emails, or for some reason there's just other data issues here. So we're just going to, if there's an error here, basically kind of help fix that issue. So we can save that copy. And we also want to start doing score bands. So we're going to use this example of click rates for score bands because I think there's a really natural use case, because maybe a student with 100% click rate just shouldn't be scored higher than students with a 90, 70, 50, 30% open rate, because they just have a system that's opening all the emails for them. And we do get a lot of flexibility in creating score bands, but also applying scoring rubrics to those score bands right here in this formula. So we're going to do another case when for Excel folks. That's just like basically an if statement. So we're going to do a few of these. So I'm going to open up our formula box. So when the click rate, so the number of emails clicked divided by the number of emails sent, is greater than or equals to 1. So this is 100% essentially click rate because we're doing percents. Then we're just going to give them 0 points or put them in that 0 score band. And definitely check your data. This is kind of assuming that you've examined your data. What are the groups of maybe similar sizes, similar outcomes, or validation variables that you're using to group these students for whatever maybe scoring, yield, messaging strategies, whatever it could be. So if they have a 100% click rate, then we're just going to kind of throw them in as a 0. So you don't need the second case, you're just going to do another when statement. No, it'd help if I said then and not the. So, and I'm just going to copy this. Be careful with how you're copying and pasting. Here, that's definitely going to be another source of possible errors. So when that is, let's just say maybe we want to look at greater than or equals to 70%. Maybe 70 to 99.99999% they all behave in a very similar way or have similar outcomes and similar group sizes. So when their click rate is greater than or equals to 70%, we can say they are in group 3. Or maybe we're going to apply a scoring rubric of every group 1 through 3 gets 5 points. So maybe they're going to get 15 points for being in that third group, which is 70% or more. And we can just copy that again. So maybe the second group is 30% or more, and maybe that they get put into that group 2, or if we're applying a scoring rubric, 5 points per group number, then that's 10. And then maybe if it's just literally a 1% click rate, then they get thrown into that group 1, or if we're applying a scoring rubric, 5 points. And maybe we just throw everything else as a 0. So this is 0% click rates, or if there's some other kind of something else that's just falling through the cracks of how you're writing your formula, it just kind of gets thrown into the 0. And again, when you're analyzing and validating your data, if you see a huge discrepancy of the behaviors here, and you probably have a raw click rate value export, you can troubleshoot, investigate, things like that. So, and then we just need to end our case when statements. So this allows you to not only get your click rates, not only put them in score bands, but actually apply your scoring rubric to your score bands. So we're just going to save that. So now that we've analyzed our click rates, we've put them in score bands, we've actually scored the bands, we're going to look at distance. And we're going to do this kind of in 2 pieces as well, just for the sake of complexity. So we're going to first look at how far is the distance of a student from your institution. So, and we could also apply score bands to this as well. And we can look at this from their school, from their permanent address. We'll coalesce this in a little bit based on other filters. Like I'm concerned, or I want the data of domestic students. So maybe we'll cover that later. So we're just going to measure the distance from the institution to the student's school. And we're going to join school. Oh. Let's not do a coalesce. We're going to do a more complicated formula, but we're not going to mess with applying filters to the school. So we're just going to do school by rank overall. Maybe you are concerned of you want the rank, the highest rank or lowest, like rank 1, high school, undergrad, graduate school. But we're just going to do school by rank overall right now. We're going to do that school 1. And we're going to do another join to organization. And this is Slate's data set of organizations. That way you're going to get that Slate system of record address, or if you have contact for the organization, anything like that. This just gives you that cleaner data. But that we might also be missing some students that aren't getting mapped to the organization. Maybe they don't have their SEEB code. Maybe the institution's not set up as an organization yet. Or maybe they just didn't use the drop-down in your RFI application, whatever it might be. It's just something's happening where it's not mapping to that organization. We'll deal with that in a little bit. So we're joining from person to school, that school rank 1, from that school rank 1 to the organization that's going to feed it that really precise vetted information. So we're going to set up a formula now. And we're just going to do distance from campus, and we can do that with we're going to geography, latitude, longitude. And we're going to join from organization to, and we'll probably just do the rank overall. You could do mailing permanent, but we're just going to do that rank 1 overall. And we need to actually modify this here. So we need to actually compare that school organization address with your institution. So you can just look this up, what your longitude and latitude is. I'm just going to copy and paste these over. And maybe we just throw a real format type here so we don't mess up any mathematical formulas that you might be doing in comparisons. And this is just, yeah, this is how far the student's school, high school is, let's say, to your institution. And being able to measure that impact or how students from similar distances behave. There probably is a lot of nuance there. So we can just save that. And maybe we want to look at this in a little bit more of a complex way or handle some possible data issues that you're going to run into. We could do another coalesce, but that's going to require those subquery export joins, and I don't think that's the right move at this point. So we're probably just going to write a more complicated formula with a couple additional exports. So we're going to create a subquery export here, and maybe this is just distance from campus, miles, school, then perm. Like I was alluding to earlier, maybe we want to know in a more domestic sense of if an international student is going to school in the States, or if a domestic student is going and studying abroad. We care more about what is their domestic address distance from the institution than maybe they happen to be out of the country right now, and we'll do some additional fallback values for that as well. So we're just going to do another formula, and let's do that geo latitude again. So we have that address 1, and maybe let's do this again. Geo latitude. And we're going to do another extended export here because I should have joined earlier, but I didn't. So we're going to look at the person. Yeah, let's do type and rank. So we're going to do permanent address, rank 1. And I'm just going to name this person address. Probably should have done the rename for the school as well, the organization as well, but I didn't. So, and let's just say this is just for simplicity's sake, school. Take that to real as well, just in case. And maybe this is just person. Real. And let's so we have our two distances, and now we're going to build some criteria here. I just want to know if the school is domestic, then I'm going to pull the school. And again, you could kind of nest this in the exports, but we're just going to do this in a little bit more of a straightforward way. School, domestic. I'm just going to do an existence export. 1 or 0. And then we're just going to do a filter of, is the organization country, which is that address 1, because we want the organization address, not the school on the student's school data table. We want the actual organization address. If that country is in the United States. So instead of an existence, we could also just export that geo lat longitude piece. But we're just going to write this into the formula. And maybe we just do person domestic. My typing is getting worse. And we're just going to do that person, address by type rank. And we can just do United States again. And we're going to remove that school address filter and just save a copy. And this allows us to write another one of those case when statements of case when school domestic in, and I mean, we could, whatever value, you could do a word, yes, no, you could do a number or whatever it could be. Then I want to give me the school one, or the organization, the distance from the organization address to your institution. And then when, so if that is in domestic, it'll give us that distance. If that's not true, it then checks down to the next when statement. So when person domestic is in 1, again, whatever value you're using. Again, this could be a coalesce, with this being a little bit more complicated. Then just give me that permanent or person distance. And then maybe else, we just say it's 3,000 miles away. 3,001. Not very precise. A student in California attending a school in Mexico, or someone in New York attending a school in Canada, it's definitely not going to be 3,000 miles, but we're also going to bucket these into groups as well. So this just gives us a value that we can compare against. Oh, and it would help if I ended our case when statement. So now that we have the distance from campus, and this is going to be that school, domestic school. If not domestic school, then domestic perm, and if not domestic perm, then just that static value of 3,000. So we can do another case when statement. And you could also use translation codes to do your score bands and scoring rubrics. I typically would not recommend that unless whatever your band is going to be pretty universal across your instance of Slate. So if you know, like, whenever you're working with institutional distance, yeah, 50 miles, 100 miles, 200 miles, that's always the criteria, or it's the criteria for 99% of the cases, then yeah, you can build a translation code to work with that in several different ways. But you might find that either at the student level, prospect, inquiry, applicant, admitted students, those distances have different nuances with your students, whether that's engagement, likelihood to perform behaviors, whatever it might be, but also at the round level. And those kind of cutoffs for an ED student might be different from a regular decision student, might be different from a transfer student. So if you do have a lot of nuance with what these cutoffs are going to be, these export-specific formulas, and you could add these different cutoffs to like a query library, a configurable joins query library, and still have them readily available. But having them at the export level, and especially a year-over-year level where this might be changing, could definitely help prevent confusion over a billion translation codes that could be cluttering up your translation code section, or just people don't know which one to use, or they might choose the wrong one on accident. So we're just going to build this directly into the formula. So case when that distance is, let's just say, greater than or equal to 400 miles, then we're going to put them in that third bucket. And then when distance is greater than or equal to 100 miles, then we're going to put them into that second band, bucket, whatever we're going to call this. And then when the distance is maybe greater than 0, then 1. Or maybe we just want to do greater than or equal to 0. And again, I'm kind of falling into that else territory, though. So maybe 0, I mean, I realistically, you're going to be 0 miles away from the institution, probably not. So we're just going to do, and we'll do greater than or equal to 0. And then, I mean, else, just 1. And then we're going to end the statement as well. So we're not applying a scoring rubric. We could, but we're just putting them into bins to maybe help with strategy, outreach, scoring, modeling, whatever it might be. And then person perm. So we're going to save a copy there. Next up, we're going to do what is essentially the second half of the Slate Summit presentation, which is time-anchored behaviors, login streaks in that historical tracking entity. But we're going to close it up here for now as kind of a standalone video.
This is the Blueprint Breakdowns, your quick reference guide after a discussion or chapter. Here, we extract the essentials, highlight key points, and help you carry clear takeaways back to your daily work. No guesswork needed. What are the key takeaways from today's conversation?
We'll do a quick blueprint breakdown for this session. Really what we're looking at in the first video is counting behaviors, creating score bands, the distance piece, and what we're trying to do is understand the student better in a way that allows us to engage with them in a more helpful way, increase their student success, increase the institutional success. And really what we're trying to do is build smarter exports. And we're leveraging flags and scores to turn these behaviors into more structured insights that can be ready for modeling, strategy, action. And it's when you start thinking like a modeler that this feature engineering can help you explain, predict, provoke questions even. The goal isn't just to describe what the student's doing, but it's actually to discover their journey and how you can aid them in that process. It also helps you target your outreach. And this could be flags and counts to help define those micro segments, those kind of quietly engaging, or maybe those are just slipping away, and use this to personalize your yield strategy for them. And you can also just start packaging your Slate insights in a way that is easier to communicate and easier to operationalize. So we're able to not just say, okay, well, we know students are attending events, but we can actually start looking at what that behavior leads up to and is correlated with and predictive of those pieces. So I hope that if nothing else, this is just a foot in the right direction for you to start taking a more active approach to your data management and how you can start scoping and delivering a student journey that is very artisanal while also being able to do those more automated pieces of content blocks, translation codes, strategic outreach to the students that are going to have the biggest impact. Until next time, we'll continue to pluck away on my side on these videos.
For those watching the video or willing just to see our next mascot, I need a name for our segment, The Consultant Cadre. Send me an email at theinnovationforagepodcast@gmail.com or find me on the socials like LinkedIn and Instagram to comment your suggestion. As always, I'll send the ebook of The Innovation Forge to all winning name submitters. If you enjoyed today's episode, please grow the guild by rating and reviewing the Innovation Forge podcast or sharing it with a colleague who needs to hear about these creative crossovers in education. The best review or comment every month will get an ebook of my book, of course. Particularly great ones will also be featured on future episodes. Thank you so much for joining me in the workshop today. Remember to strike true, and let's forge something extraordinary together.